So in this lecture we are discussing about the battens. Okay. Generally, where we provide this lacing is battens. In case of built-up column, what happened in built-up column? We are using two individual components. Now we want to tie them together. Okay, we want to tie them together so that this section act as a single or unit section. That's why you use defined members. One member is called the lacing, another member is called the battens. Why we use lacing? Where this generally this spacing is little bit higher side and eccentric loads are there, we go for a lacing system. When the spacing is very close, okay, and axially loaded columns are there, we go for batten systems. Okay, or sometimes we can combine both battens and lacing together also. In many cases you may find that battens and lacing both are given together. So lacings, how to design the lacings or what are the different guidelines given for the lacing that we have discussed in the previous class. So this class we will be designing or we will be discussing about different guidelines given in the code books on the design of a battens. Okay. So first guidelines, if you say that is saying that the battens should have preferably the same cross-sectional area everywhere, and it should be placed symmetrically above their x-axis. Okay, it should be placed symmetrically about their x-axis, and similar to the other, that radius of gyration about y axis should not be less than radius of gyration about x axis. That means, that's what you can see, that if you have a battens, then you find out the radius of gyration about the perpendicular of the battens and find out the radius of gyration about the same direction of the battens, and the radius of gyration about perpendicular to the axis of the battens should not be less than radius of gyration about the same axis of the battens. That is, it is saying that ry should not be less than r as far as possible. So for a symmetrical column we try to keep ry is equal to rs. That means finance ratio in both the direction will be equal. So that is the first requirements or first guidelines for a battens. Second guidelines, it is saying that the batten should be placed in opposite to each other at each end of the member. Suppose what we have a column member, say this is the column, these are the two columns we are fixing with, say, battens. The battens should be provided here, as well as same battens should be provided at the same location in the opposite direction also. That means if you look at this, here one batten, on the other side also same location, same dimensions, battens is to be provided. Okay, spacing, everything should be identical. Next guideline is saying that the number of battens should be such that the member is divided into not less than 3 parts longitudinally. Okay, that means what it is saying, so this is one column member, so this side another member of the column is, it should be equal. Then our battens should be, say, one battens is provided here. Okay, at the end, so we have provided another batten. So what it is saying, guideline is saying that should not be less than 3 parts longitudinally. Okay, that means if you provide at least 3 parts, so how many battens are to be provided? Minimum 4 battens are to be provided. Okay, so how many parts? 1 part, 2 part, 3 part. It should not be less than 3 part. That means it should have a minimum of 4 battens, including the end battens. Okay, minimum. It can be more than that depending on the requirements. So that is the third guideline. Fourth guideline is saying that the effective length of batten column should be increased by 10%. We know how to find out the effective length of the column depending on the support conditions or the end condition. Whenever we are designing the column in the batten member, it should be increased by 10%. And remember that battens are generally provided in case of axial loading, and when the spacing between the two members of a built-up column is very less, as far as possible very close, so to tie up them only we provide the battens. Okay, so these are some minimum general requirements for designing the design of battens. Now let us go for let us see what are the codal provision given for design of a batten member. Before I go for the codal provision, let us see different symbols I have used, or symbols is used in these pictures. What are those symbols? Let us know the meaning of those symbols. If you see, first of all, say we have a column, this column. So this column have a center line, so this is the center line shown here. Okay, so this column is the center. Basically this is the wave part, so this wave part is shown here. Okay, then in this batten what is shown here, that two lines of the rivets are given. Okay, so this is one line and this is another two lines. Same things are given. This is another line, this is another line, and this is another line, and this is another line. Okay, so center to center distance, again I am saying center to center distance between the two member of the columns is denoted as A. Okay, so this is the center to center distance between the two members of the column, so don't be confused. Column CG of the column, basically CG of the individual column members again. So this is the CG of this I section in y direction, this is the CG of this I section in y direction, so their center to center distance is given as A. Fine. This S is the CG of the rivet group. Okay, again I am telling CG, you take the center of gravity of this rivet group, take the center of gravity of this all the rivets, then find out their distance. This distance is given as S. Okay, denoted by S. S is the center to center distance between the CG of rivet groups. Fine. Now center to center distance between the inner end of the rivet groups. So this is the center to center distance between the innermost connecting rivets, you can say. So this distance is denoted by L suffix B. Okay, again I am telling L suffix B is the center to center distance between the inner line of the rivet. This is the inner line of the rivet, this is the inner line of the distance. S is the center to center distance between the CGs, or you can say CG of the rivet groups. Distance between the CG of the rivet group is denoted by S. Fine. And A is the distance between the CG of the column member. So in this photograph it is showing that S is equal to A. When we have a single line of rivets, maybe I can provide here or I can provide here. In that case LB and S will be equal, because I cannot provide the rivets exactly at the center of this column because there is a web. So S, in that case LB and A will not be equal, never be equal. Okay, but LB and S can be equal, or this in the one case LB and S can be equal, another case S and A can be equal. So these are the meaning of S, A and LB, the symbol I have used. Okay, keep this in mind, otherwise there will be a confusion. This capital D is denoted as the overall width of the batten, or you can say depth also. Okay, outer to outer depth. Okay, now from inner rivet to rivet distance is denoted by small d. Okay, so the edge rivets in this side and edge rivet in this side, then find out the center to center distance. This is denoted by small d in this case. Okay, so that is clear, the symbols that what we are using. B is the width of the plane of batten. Okay, basically if you see the other direction, okay, which this one. this one is B. Okay, if you look at this section, this thickness you can say is basically denoted by B. Okay, so these are the different symbols that we have used. Now we will see how the battens can be designed based on the different codal provision. So first, okay, well, one more thing. This is the center to center spacing of the batten C. Okay, center and center you take and then C. Now codebook is given how to design this. Okay, first guideline is talking about the center to center spacing of the batten. Okay, before I start this B, what I said, B is not the thickness of the batten. Basically B is this one. Okay, thickness of the flange of the column member. Sorry, B. This is B. This is the thickness of the flange or width of the flange of the column member. Okay, so this is the width of the flange of the column member, and T, not B. This is T. T is the symbol used for deciding the thickness of the batten. Okay, so T is the thickness of the batten. I am using the standard symbol that is used in this reference figure, whatever I have used here. So based on that I am telling. The T is the thickness of this batten. B is the width of the flange. Okay. Now for design purpose, the codebook guideline is that what is the value of C. Okay. So let us see how to find out the value of C, or what is the codal provision given for finding out the C. What codebook is saying that this C divided by RC minimum should not be greater than 50 or 0.7 times lambda, whichever is less. Okay, so the codebook is saying that the spacing, center to center spacing of the batten should be such that C divided by RC minimum should not be more than 50 or 0.7 times the slenderness ratio of the compression member as a whole about x-axis, that is parallel to the battens, whichever is minimum. Okay, so now what is this RC minimum? RC minimum is the minimum radius of gyration of the column member. So since we have this column member or this column member, this will be same dimension, same everything. So what is the minimum radius of gyration of this column member, you find out. Okay, so C divided by RC minimum, that value greater than or equal to 50 or 0.7 times 0.7 times the slenderness ratio of the column member about x-axis, this axis. Okay, parallel to the battens. Parallel to the batten is the x-axis, so x-axis you find out. Out of these two, whichever is the minimum that you take, then C, and this minimum will multiply by RC. C is, what will happen? C will be greater than or equal to whatever the minimum value you are getting. Let us say this is x multiplied by RC minimum. Okay, so this is how we can find out the spacing. Now once you decide the spacing, then check whether you are getting a suitable number of bays or not. Suppose total length divided by C you are doing, and then you are getting the 7.8. So in that case what we will do, because since it is saying that C should not be greater than, so we will take a total number of center spacing as 8 or something like that. Means we have to remove the fraction, and based on that we will decide what will be the exact value of C, but in any case it should not be more than this value, whatever it is. Okay, so that is the fine thing. Next, step is, let us see how we can find out this small d, the basically the dimension it is talking about. Okay, there are two criteria there. One is for end batten and another is for intermediate battens or any battens. Okay, what this guideline is saying that this small d, either of the small d or capital D we have to find out. Then if I know the small d, then I can find out the capital D easily. It is saying that this d should be greater than 3/4 of a for intermediate batten. Intermediate batten means this is the intermediate batten, this is the intermediate batten. So d must be greater than 3/4 of a. A is known to us. So this is for intermediate batten. Okay, or d must be greater than 2 times of d. Okay, so this is b, so 2 times of b we have to take, or 3/4 of a we have to take, and based on that we can find out what will be the value of d, right? So out of this, obviously whichever will be the maximum, that will be taken. So d should be greater than equal to 3/4 a, and d should be greater than 2/2b. That means out of this, whichever will be the maximum value, that we have to take as the d value for intermediate batten. Now for end batten, that means say for I am talking about this one and this one. In this case, what is saying that for end batten, d must be greater than a and d must be greater than 2b. So this is a, so this d value, thickness d value should be greater than a and should be greater than, out of this whichever is the maximum, that will be adopting, and that way we can find out what will be the d value. Okay, once you know this small d value, then what will be the capital D? Capital D will be equal to small d plus, now decide some edge distance depending on the rivet diameter, something so 40 mm or 35 mm. So this side 35 mm and this side 35 mm you get, so under 70 mm you get, that will give you the overall D. Fine. So now D is known to us. Next part. Okay, then let us see, find out the thickness of the batten. Thickness of the batten T. The guideline is saying that the thickness of the batten must be greater than LB divided by 50. What is LB? LB is the center to center spacing of the inner and rivets. So this you have to decide. Okay, depending on the column dimension, where how many lines you are providing or where will you provide, or initially you can assume some values. Okay, let us say if this distance is known to us, or if this spacing is known to us, then say minimum 60 spacing will keep this set, minimum 60 spacing will keep this set. So this value will be this center to center, this S to S spacing plus 60 plus 60. So that will give me the LB. So LB divided by T must be greater than LB divided by 50. That's clear. So now dimensions of this batten or the end batten, whatever is known to us. Then slowly we are going to check whether our design is safe or not for checking purpose. Okay, dimension is known to us. Now see how much design load that will transfer to a batten. If we just see the earlier discussion, we have said that in case of lacing system, 2.5% of the total compressive force is transferring to the lacing. Similarly to the battens also, design shear will be equal to 2.5% of the axial load. That means what we can say, that the B will be equal to 2.5% of P, right? So now design shear force is also known to us. Okay, So let us do the remaining part, that is how to find out the force and shear. As I said that the design shear force B is equal to 2.5% of P. Now this design shear force in case of battens will give two components. One component is the longitudinal shear, that is I have shown here as B1, and another component is the moment. Okay, and there are two planes in this batten. So this B1, basically this B will be divided into these two planes. So 50% on the top plane and 50% on the bottom planes. So based on that we can calculate the value of longitudinal shear B1 as per the Codal guidelines. I am saying that directly, that this B1 will be equal to B into C divided by N into S, and the value of this moment M is equal to B into C divided by 2N. Now question is, what is B? B is the design shear, that is 2.5% of the P. What is S? The minimum transverse distance between the centroid of rivet groups or welding. That already I told, and if you see the figure, center to center distance between the rivet group. It may be single line, then S and TB will be equal. If it is a double line, then S and A will be equal. So this is what is the S, this is the B. What is the C? This C is the center to center spacing of the battens. Okay. What is the N? N is the number of parallel planes of batten. Okay, so this is one plane and this is another plane. So this N value by default it will be 2. Okay, we will take this value as 2. So this will give you the longitudinal shear and this will give you the moment. Moment is equal to B into C divided by 2N. So 2 into 2, that is equal to 4. So this is how we can calculate the shear force and the moment. Once we go this find this value, then we have to do the checking part. That is, from shear force we will check the shear stress. And from bending moment we will do the bending stress. Shear stress is nothing but what we know, shear force divided by cross sectional area. So cross sectional area will be how much? B into thickness of the plate. D is the breadth, you can see, and T is the thickness. So B1 divided. This should not be more than permissible average shear stress, tau BM. Okay, average shear stress is equal to 0.4 Fy. That means this value is equal to 0.4 Fy, means how much? For Fe250 steel, this will be 100 MPa. Okay, so shear stress B1 divided by D into T should not be more than 100 MPa. That is one thing we got. D is the overall depth and T is the thickness. Then we have to calculate the, for bending moment we have to calculate the bending stress. Okay, let us see that. Bending stress is equal to M divided by Z. What is that? Z. Z is the section modulus. Or if you are confused about this Z, then quickly see here what is Z. Z is basically equal to I divided by Y, moment of inertia divided by center. Okay, moment of inertia is how much? Moment of inertia is d T cube Okay. Now see, in this case we are getting two information. One is the longitudinal shear and another is the moment. That means if you go for a eccentric connection, suppose you are doing a riveted connection, then you consider it as an eccentric connection with direct force V1 and moment M. So for that case, what you do, you assume some rivet values, find out the you assume some rivets with some diameters and find out the rivet value. Then direct force divided by the rivet value will give you the number of rivet recurrence. Now increase it to 3 times, right? That's what we need. Then you calculate the force due to the movement at the farthest rivets. Okay, calculate that value that we know. If you remember that we know as FM. So once you know the FA value and then FM value, then you calculate the net force. Okay, so the net force acting on the rivet must be less than the rivet value. That is what we did if you recall the eccentric connection. So same guideline is to be, or same step is to be followed here when this is a riveted connection. अरे यार Okay, so this is the design guidelines for welded connection. In case of welded connection, again you have to design it for a longitudinal movement, longitudinal force V1 as well as the moment M. So what is the guidelines for welded connection? The left should not be less than 4 times the T thickness. the total length of the weld at the edge of the batten, okay, in this edge of the batten, this total length, it should not be less than d upon 2, okay, 50% of d. Length of the weld at each edge of the batten, at each edge of the batten, basically talking about the edge, should not be more than 1/3 of the total length of the weld required. Return weld along the transverse axis, okay, this is talking about should not be more than 14, where T and D are the thickness of the and overall depth of the batten respectively. So this is what it is saying, that A plus B plus, you can see here, this is A, that is end connection, B is the center part, and C again the end connection. The total should not be less than d by 2, that is the H. So total length of the weld at the edge of the batten. So A plus B plus C, this should not be less than d by 2. Okay, so this is the left, this one, it is talking about the left, this should not be less than 40. Okay, so this is simply summary of the guidelines for design of the battens. Okay, now what we will do in the next topics, we will take a built-up column and we will start from the scratch. We will design the built-up column using this, what is called lacing, as well as the battens in the next lecture, maybe in 30 minutes. Okay, so that's it for this design of the battens.